All right, so now a new derivative rule for us, actually two derivative rules. The first one is that e to the x's derivative is simply e to the x. So that is the most beautiful thing in the world to me. Well, maybe not the most beautiful thing, but it is very beautiful. The fact that when you take the derivative of e to the x, it just goes to e to the x. Now, if you apply the chain rule to this e to the x function, then our e to the u rule is developed. Now, I just want to take a quick minute and talk about this. This is purely for your information. If you want to skip to the next video, that is totally fine, but I'm just going to take a minute and talk about why this is. So the situation is that if you have the derivative of just e to the x, then it goes to e to the x. However, if it changes to anything besides x, so if it becomes like a 5x or x squared, anything that's besides x, then what happens is this 5x is an inner function. So because of the fact that the 5x is grouped together, it's an inner function, that means that we need to use the chain rule. And to use the chain rule, remember we had that whole derivative of the outer times the derivative of the inner function. So the chain rule would say that our outer function would be this e to the power. So the derivative of e to a power by this, or e to the u I should say, is going to be e to the 5x. But then because we have this 5x in our function, we then have to multiply by the derivative of 5x. And so that will just be 5. So the chain rule applied to e to the x is going to give us, we rewrite the exponential and then we multiply by the derivative of that inner function. So instead of going through this every single time, what they do is they present this as we're going to have e to the u as our e to a power, and then we multiply that by u prime. And u prime here is the derivative of the exponent, which is referring to the inner function. So that's why you're going to see in our notes here that we're going to say that anything besides just x is going to take this form of e to the u times u